Welcome to Algebra 1, Semester 2, Unit 9, Sections 10.3 and 10.4. Okay. What we're doing here is we're going to solve quadratic equations by graphing. Basically, we're showing when the y will equal 0. In a graph, we graph it as y equals x squared plus 11x plus 30. And that's how we graph it. But when we're looking at the solution for when y equals 0, where it crosses the x-axis, we actually take that y and we set it to 0. So when we do that, we can just go ahead and factor this. Factoring, we can see that our leading coefficient is 1. So we can take the shortcut and we say x goes here, x goes here. We need two numbers that multiply to be positive 30. That means that their signs will be the same because they're going to be positive 30. Since the middle number is positive, then we know these two numbers must both be positive because they're going to add to be the middle number, multiply to be the outside numbers. And this is 1, so 1 times 30. Okay, so we think of all the factors of 30. We would have 1 and 30, 2 and 15, 3 and 10, 4 and not 4, 5 and 6. Those are our factors of 30. Which of those would add up to be 11? 31, 17, 13, 11. So we know that the factors are 5 and 6 equals 0. So what I'm saying is when this equals 0 or this equals 0, then the whole thing is crossing the x-axis, or the whole thing is equal to 0. So what value would cause this to be 0? Well, that would be at -5. What would cause this to be 0? That would be when x is at -6. So we come up to the graph and we see those are the points that we're seeing right there, -6 and -5. Two ways to see that. Next one. Fortunately, we have a 1 in front again, so we can take our shortcut. We bring our x here and here, and we say, what two numbers multiply to be 3 and add to be 4? Well, the only factors for 3 are 1 and 3. It's a positive 3 and a positive 4, so it's 1 and 3. When will x plus 1 be equal to 0? That would be when x equals -1. When is x plus 3 equal to 0? That is when x is equal to -3. If we look up at the graph, we're proving the same point here and the same point here. This is -1 and this is -3, just like you solved here. Let's see what happens here. Notice how we aren't crossing the x-axis. What do you think that'll look like in the equation? Because obviously there's no solution here if it's not crossing the x-axis. So let's go ahead and do this. We have -x squared minus 2 equals 0. We don't need to factor because we have no middle term, and we have a negative off the front, so this starts looking a little bit complicated. Well, we get rid of this 2. Let's just get the creepy dude by himself. Even though it's an x squared, maybe we can deal with this. Now to get rid of that negative, we would multiply each side by a negative or divide by negative. So we'd get x squared equals -2. Get rid of a square, how do you do that? Well, we square root it. Square root of x squared will equal x. Here's the problem. Square root of a -2. What two numbers multiply by themselves to equal a negative? We have a negative and a negative, it makes a positive. Or a positive and a positive, it makes a positive. This is actually an imaginary number. So that's why it doesn't cross the x-axis. That's how it's going to look. So you write simply here, no real answer. There's no real answer. It's an imaginary answer. Going to the next graphs, you're asked on this page to go ahead and find where it's crossing the x-axis. Well, we can see that it's a mini, and because you've been doing the sheets on the back of the packet, hopefully you've been doing these back page sheets. They're transformation activities with quadratics. Actually just one sheet there. You should be doing that in class. If you haven't been, this might be a little bit confusing, but make sure that you do it with me and with your small group in class. So we have a negative here. We know that means that it's going to be the maximum shape. And this is an H shift, so we're taking our vertex at 0, 0, and we're shifting 3 to the left. Remember, the H always goes the opposite of how it looks. So we come over 1, 2, 3, and now the plus 9 means that we go up 9. So we go clear up to there. That's where our vertex is. And we just draw a little sketch of how it's going to look. Now, the problem is, I said, well, can you find the zeros? Can you find where it's crossing the zeros? The easiest way is to set y to 0. And I didn't mean crossing the zeros, I meant crossing the x-axis. So set y to 0, negative x plus 3 squared plus 9. Okay? So the first thing that I would do is go ahead and square that. So we get x plus 3 times x plus 3 equals x squared plus 6x plus 9. Plus 9 out there. Now we have a negative out front. Let's go ahead and bring it through that. So we have a negative x squared minus 6x minus 9 plus 9. Well, this minus 9 and plus 9 are going to cancel each other, aren't they? And we end up with 0 equals negative x squared minus 6x. We can't, well, we don't really like to factor with a negative in there, so let's just pull it out along with the x. So we have negative x times x plus 6, because a negative x times positive 6 will make negative 6x. Now, we know in order for these two products to equal 0, each one needs to be equal to 0 at different times, but negative x equals 0. Divide each side by a negative, you'd get x equals 0. X plus 6 equals 0. That occurs when x is equal to negative 6. So we know that it's crossing at negative 6 and 0. So we can extend our graph through those points and show that that parabola has the solutions, the zeros of 0 and 6. Okay, next problem. We can see this is in the same format, the shifting. This is our h value at negative 3. Remember, it's the opposite of how it looks because of the negative h, so that's really at a positive 3. there's our vertex. 3, 0. There's no up or down shift, and it is a U shape because it's positive out front. So we know that it's going up as a U. That also tells us, since it's going up this way and the vertex is at 3, 0, that automatically gives us the solution of 3, 0. To show that algebraically, we would have y equals x minus 3 squared, set y to 0, x minus 3 squared. We need to get rid of that square, so we take the square root of each side. Square root of x minus 3 squared, that wipes out, and we get square root of 0 is 0, x minus 3 equals 0. Bring the 3 across, or add 3 to get rid of it there, and we find that x equals 3. That's the same answer as we get graphically. It's always nice when it works out. Both the same thing. Okay, next problem. This one's in standard form. Okay, so let's go ahead and bring these two terms across just to get that x squared is positive. So we have x squared minus 2x plus 1 equals 0. Now, we're wanting to find where this crosses the x-axis. That's why we set the y to 0. We can think of our factors. Two numbers that multiply to be positive 1 and add to be negative 2. That would have to be a negative 1 and a negative 1. So we know that when x equals 1, this equals 0. So it's only going to cross at 1, 0. Let's think about that. If it only has one x solution, 1, 0 solution on the x-axis, which graph must it be like? This one or this one? Let's go ahead and plug in a couple other values. Let's see what this 0 or the y-intercept would be. We know that that's our c value from previous graphing, so we know that it goes right there. Now, that should give you an idea. Well, this probably is the mirror image, and that's our axis of symmetry. Let's just double check that that is. Axis of symmetry is negative 1/2 times b over a. Well, our b value is negative 2. Our a value is 1. Negative 1/2. Negative times a negative is positive, and 2 over 2 is 1. So there's our parabola. And our solution is x equals 1. Last graph here. Again, it's going to be in standard form. So we're going to bring this 4x across here this time because we want to keep that x squared as positive. So we have x squared minus 4x plus 7 equals 0. We just need to think of our terms that will multiply to be 7 and will add to be negative 4. Well, we look at that, we say, can't think of any terms. 7 and 1 are the only factors I can think of, and they don't add to be negative 4. So let's go ahead and graph it and see if we can find the solution that way. So our axis of symmetry is negative 1/2 times b over a. Our b value is negative 4. Our a value is 1 times negative 1/2. Negative times a negative is positive, and 1/2 of 4 is 2. So we come over here to positive 2. That's our axis of symmetry. Now we need to plug in that x value, that positive 2 value, to find what our y is. So if we plug in 2 squared, that would be 4, minus 4 times 2 is 8, plus 7 equals 0. Well, we don't know what it equals actually. We're looking for that. We're no longer looking for the zeros, we're looking for the y value, so we should have equals y. So 4 minus 8 is negative 4, plus 7 is positive 3. That is our vertex. So we come over here to 2, 3, and this has a positive leading coefficient, so that tells us that this is a mini, and that's why we can't find any factors, because it does not cross the x-axis. It has no real zeros. So that should help you on those. Now we're going to go into solving just the equations without any graphs. Okay? So you're given a quadratic equation here. Go ahead and do like you've done in the past. If there's just an x squared or just a quadratic term and no b value in there, no x to the first power, you can go ahead and go up the PIMDAs and solve it just like you have in the past. So going up the PIMDAs, there's nothing being added or subtracted. There is a 2 being multiplied, so we divide by 2. We get x squared equals 4. Now we say, well, get rid of that squared, we would need to square root each side. So we find that x equals, now here's one tricky part, is it could be positive 2, because 2 times 2 is 4, but it could also be a negative 2, because negative 2 times negative 2 is 4. So we've got 2 possibilities. And if you think of this on the graph, you would actually have it going across at positive 2 and negative 2, doing something kind of like that. Okay? On B, again, we have just a variable squared, so we can add 18 to each side to get that variable alone. That'll cancel. We get m squared equals, oh, this is 0. So we know that m is equal to 0 because the square root of 0 is 0. Here we subtract 12 from each side to get that b squared alone. We have b squared equals negative 7. To get rid of the square root, or to get rid of the square, we would square root each side. Now we have a little problem, don't we? Can we have real numbers for this square root of a negative number? The answer is no, so we just write no real solution. And underline the real. When you get into the Algebra 2 class, you'll be playing around with imaginary numbers, and then you'll be able to solve those and see what they mean. Okay, next one. Draw our line down. We're getting the p squared alone, so we divide by 4. We get p squared equals 9 over 4. To get rid of the p squared, we square root it, square root this. P equals, now remember from a previous unit, square root of 9 over 4 is the same as square root of 9 over square root of 4. And those could be positive or negative now. So we have P equals plus or minus, what's the square root of 9? 3. Square root of 4, 2. And just write 1 plus or minus out to the front. Okay. Next equation, trying to get that x squared alone. So we add 11 to each side. We get 3x squared equals 18. Now we're going to divide by 3 on each side to get that x squared alone. So we end up with x squared equals 6. Take the square root to get rid of the square on the x. We find that x equals a plus or minus radical 6. Now, You might be a little bit uncomfortable with that because it's not a perfect square. That's okay, it's still a real answer. If we plug radical 6 into a calculator, we get an irrational number that is a decimal that goes on and on forever, but it's still a real number. It still fits in there. It is between 2 and 3. We know that because the perfect square of 2 is 4, so the square root of 4 is 2, and the square root of 9 is 3. So we know that it's between 2 and 3 on our number line, so we can still kind of picture it in our graphing. Okay, next problem, just a slight variation here. We have this whole thing being squared, so we need to get rid of that 6 out there first, so we divide by 6, and we have x minus 4 squared equals 7. To get rid of that square root so that we can get in here and take care of that 4, to get rid of the square so that we can get in here and take care of the minus 4, we square root it. So now we have x minus 4, because it's going to cancel the square, equals plus or minus radical 7. Now we see that we need to add 4 to get that x alone, so we have x equals 4 plus or minus root 7. Again, that is a real number, even though you have a radical left in the answer. That's the end of this section. We'll see you tomorrow in class. You'll get to practice these and ask all the questions you want. Please come to class with questions.